Okay, ada orang baru masuk. Ada orang baru masuk, please sign in your attendance on Putra Blast kalau belum. Okay, and don't forget you have the demonstration for web assign tonight by the company yang buat platform ni. Okay, draw. Okay, I think I forgot to say good afternoon to everyone. Good afternoon, everyone. Dr. Nat here.
Good afternoon, Dr.
Good afternoon, Doctor.
Okay, so kita akan buat chapter 2 today. Chapter 1 is over. Please do the assignment. If you have difficulty answering any question, you can discuss with your friends and you can also ask me. Okay, boleh. No problem with that. It's not the exam. Okay, so for chapter 2, we are learning on linear kinematics. So I think this is a new term for you, kinematics. Kita akan discover what is kinematics. So in this chapter, we are learning about translational linear motion, uniformly accelerated linear motion, free fall, projectile, and graphical representation of all of this. Okay, so let's go to the first one. So the outcome, learning outcome for this chapter is you need to know how to define, and also know how to calculate displacement, velocity, and acceleration. Use linear kinematic equations for uniform acceleration. Okay, solve free fall problems and solve projectile motion. So saya target hari ni kita akan boleh habiskan these two topics lah. Free fall and projectile kita akan go for the next class. Okay, hopefully. So is this important? No. Next. Okay, so kinematics is the branch of physics involving the motion of an object. So kinematic ni describes a motion lah and the relationship between that motion and other physics concept. Kinematics is part of dynamics. So kinematic ni is the description of motion and it is not concerned about the cause of motion. Contohnya, this is, nak cakap siapa? Kita cakap Haikal lah. This is Haikal. Haikal is flying. Okay, he's flying and then dia jatuh kat sini. Kesian Haikal. So in kinematics, I describe this as Haikal is going up, stops momentarily, and falls down. That is the description, right? And kita tak tahu apa yang berlaku kat sini, siapa yang tolak Haikal, siapa yang benda apa yang melonjakkan Haikal, kita tak tahu. Sebab kinematik ni dia tak kisah apa yang dibuat pada Haikal, tapi dia nak tahu macam mana motion Haikal ni. It's just concerned about this. Haikal naik atas, Haikal turun bawah. Haikal pergi kanan, Haikal pergi kiri. Tu je yang dia nak tahu. Dia tak kisah ada orang tolak ke, Syeki tolak Haikal ke, dia tak kisah. Dia macam lantak lah. Aku nak tahu apa jadi kat Haikal punya motion je sekarang ni. That is kinematics. Okay. Untuk dynamics, kita akan belajar kemudian. Dynamics kita akan belajar apa yang menyebabkan Haikal melonjak. So that is another chapter. Okay, so kinematics, we are only concerned about the motion punya description. Okay, so we have several types of motion. Translational motion, change of position. So translational motion, nama dia translational. It can happen in linear, curvilinear or circular path. So linear motion is one dimensional. Maksudnya kalau saya guna x-axis, nak guna nama siapa Nama orang lain pula lah kesan kan. Kena kacau. Let's see. Vikram pun saya selalu kacau juga. Sorry Vikram. Let's use Fazrul lah. Fazrul saya jarang kacau. Okay, so this is Fazrul. Fazrul sangat kecil dalam ni. So Fazrul berjalan sebanyak 10 meter. So this is one dimensional motion. Sebab Fazrul dia jalan dekat x-axis je. One dimension axis. And then kalau ada dinding kat sini lah. Fazrul kat sini. Fazrul cakap macam menarik je nak naik atas ni. So Fazrul pun naik kat sini. Dia jalan 10 meter ke atas. Ini pun one dimensional walaupun pelik. Dia naik y axis tapi pergerakan dia 1D only. So it's still one dimensional walaupun agak tak logik kat situ. Okay. So this is called linear motion. Pergerakan in one dimension. And then we have curvilinear. Macam kita nampak Haikal tadi. Haikal dia naik macam ni. This is not linear. Sebab apa? Sebab kat sini ada X, and Y component. So this is two-dimensional. Kat sini pun ada X and Y component. Kat sini je tak ada Y component. Kat sini ada X je. So kat sini X and Y component. So because it's a curve, it can be resolved into the X and Y component, which makes it a 2D motion. Okay, so this is 2D motion. And then we have circular path. Circular path macam ni. Okay, siapa punya nama pula saya nak panggil ni? Iskandar lah. Iskandar, ni Iskandar. Iskandar tiba-tiba dia tengah baring tapi tiba-tiba dia bergerak macam ni. Dia pusing. Tak tahu kenapa. So kesian Iskandar. Tapi this is called a circular path. Sebab dia bergerak dalam bulatan. Lain macam Haikal and lain dari Fazrul. Fazrul dia naik dinding. Haikal dia melonjak. Okay, and Iskandar. Iskandar. Itu ke Iskandar? Saya panggil Iskandar tadi. Tak ingat saya. Okay, so these are the 3 different types of motion and kita akan pakai semua ni dalam semester ni. Okay, and then we have repeated motion, rotation, rolling, simple harmonic and damped harmonic motion, wave motion. So rotation, kalau kita ada bola, kesian saya tak pakai orang lah, saya pakai bola. So this is a ball, dia bergerak ke kanan dalam masa yang sama, dia berputar. Dia gerak kan? Dia gerak ke kanan tapi dalam masa dia berputar. So this is called rolling. Okay, this is a ball. Walaupun rupa dia tak macam bola. Ball berputar and also moving to the right. Dia ada dua. Dia ada ke kanan dan juga putaran. So we call this as rolling. Okay, change in position. This is X, change in position. Change in orientation, ada angle putaran. Now we have rotation. Rotation ni dia tak bergerak ke kanan, dia hanya berputar. Macam, saya tak tahu apa yang berputar. Apa? Macam kipas, Kan kipas kat atas ni. Okay, kipas yang hodoh tapi dia berputar pada tempatnya. Dia tak ada bergerak ke kanan atau ke kiri. Kalau dia bergerak ke kanan ke kiri, terputus kepala siapa-siapa. Okay, so we don't want that. Kita nak kipas tu berputar pada paksi dia and tak bergerak. So that is rotation. Okay, rotation is kipas. And then we have simple harmonic motion. Kita ada spring. Okay, bila saya tarik spring ni, dia pergi atas, pergi bawah, pergi atas, pergi bawah, pergi atas, pergi bawah. That is called simple harmonic motion. Dia pergerakan yang sama dekat tempat. Walaupun dia bergerak kanan, kiri, atas, bawah, tapi pergerakan dia sama. Berulang tapi dia bergerak, tapi dia berulang. Okay, dia bukan rotation, dia bukan pergerakan linear, dia pergerakan simple harmonic motion. Atas, bawah, atas, bawah, atas, bawah. Dia repetitif tapi ada pergerakan. And then we have damped harmonic motion. Damp ni, bila kita spring, dia bergerak atas bawah tapi lama-lama atas bawah ni makin kurang. Okay, gerak atas, bawah, lepas tu dia kurang sikit, atas, bawah, tu atas, bawah. Makin lama makin sikit, lepas tu lama-lama dia stop. So this is called damped harmonic motion. Yang kita nampak hari-hari in reality is damped harmonic motion. Tak ada simple harmonic motion. Ini adalah ideal case. Ideal case. Okay, tapi fizik suka ideal case. Dia suka benda yang perfect. Dia senang nak buat calculation kata dia. Okay, and then we have wave motion. Ini senang je macam sine, cosine tu semua wave motion. Apa yang rupa macam sine wave, apa yang rupa macam cosine wave is ombak. Apa lagi? Ombak lah kot yang paling senang nak ingat. Okay, so those are the different types of motion. Okay, so now I need to tell you about terms. Terms yang pertama adalah reference point. When we start from a point, let's say Abu, this is Abu, okay, Abu kat sini lah. Saya tak pakai nama siapa-siapa sebab kesian. Abu is at Kuala Lumpur, is in KL lah. Sorry, is at a mall. Okay, and then he moves 10 kilometer north. Okay, 10 kilometer north to KTM contohnya. KTM sebab kita pergi Mid Valley, so naik KTM. 10 kilometer kepada Valid, jauh sangat pula 10 km ni, tak apalah. So dia pergi KTM. So the initial point where Abu started his journey is called the reference point. And I think this is quite straightforward. Reference point maksudnya tempat dia bermula. Okay, reference. Kita refer kepada tempat tu sebagai initial point dia. Kita refer. That's a reference point. Okay. So that is the first term, and then we have the position vector. This is our second term that we need to know. So position vector, this is the reference point yang kita dah cakap tadi. So Abu moves 5 kilometer towards north. Oh sorry, kita tak nak pakai north kat sini. Kita nak pakai towards 5 kilometer. Nak cakap lain. Sorry. Scratch that example. So I say a ball moves a ball moves from 0, 0, 0, 0, 0, sebab ni 3 axis, to 3, 5, 4. And 3, 5, 4 is over here, contoh. Okay, so this is position vector. So what is the final position vector of the ball? The final position of the ball is 3, 5, 4. Kalau kita pakai coordinate system XYZ lah. Okay, or if kita cakap pasal Abu tadi, moves 5 km towards the north. So the final position of Abu is 5 km towards the north from reference point dia, from the reference point. Okay, so position vector ni describes the position of your object lah, ataupun the position of that person. Okay, nanti kita akan pakai pasal position vector ni kemudian. Okay, so next one, displacement. Displacement. An object that moves means there is a change in position. Okay, so displacement is defined as a vector displacement is a vector that represents the motion of a particle between 2 points. Displacement is a vector indicated by this guy or this guy or this guy. So displacement ni ada banyak simbol. Kat sini dia pakai R. Boleh. So it is a vector that represents the motion of a particle between any 2 points. So as you can see here, mula-mula our particle ni dia berjalan macam ni. Semut lah kot, ni semut. Okay, semut dia mula daripada point A and dia berakhir di point B. Semut. Macam mana rupa dia tak tahulah. Okay, so ni semut dia jalan macam tu. So saya tanya, what is the displacement of this semut? The displacement of this semut is this guy. Arrow ni kita tak kisah dia jalan bengkang-bengkok ke, dia jalan macam ni ke, tak kisah. We just want to know what is the final and what is the initial. And the initial to the final is our displacement vector. Okay, and then kalau semut tu tiba-tiba dia tukar arah, dia nak jalan dari sini ke sini ke sini, displacement vector dia tetap sama sebab A to B. Dia punya initial point sama, dia punya final point sama, maka displacement vector dia pun sama. Dia tak kisah jarak perjalanan semut ni, dia tak kisah kalau semut ni penat, lelah ke apa, tak kisah, asalkan yang dia tahu final point dengan initial point is your displacement vector. Okay, so to find the displacement vector, kita akan tulis delta x, x final minus x initial, ataupun kat sini tulis delta r, R2 minus R1. So R2 is over here and then R1, tapi kita tak akan pakai macam ni lah, kita akan pakai X final minus Xi. Okay, the magnitude of displacement is the shortest distance between the 2 points. I think you are familiar with this. Is the shortest distance between the 2 points. The direction of displacement is from the initial to the final position. Sama macam resultant vector kita, daripada initial kepada final. The displacement is independent on the path taken by the motion. Kalau dia nak jalan macam ni pun, tak ada orang kisah. Dia nak tahu final dengan initial. Okay, so that is displacement. Displacement kisah pasal final dengan initial. Final tolak initial gives me the displacement vector. This guy is a vector, sorry. Okay. Okay. Now we talk about distance. Tadi kita cakap pasal displacement. Displacement was number 3. Distance is number 4. Okay, tadi kita cakap pasal semut tu. Semut tu jalan bengkang-bengkok. Now, this is actually distance. And this is displacement. So ini perbezaan displacement dengan distance. So distance is a scalar quantity, it's a scalar. So as you can see here, I'm not labeling any arrow dekat distance because there's no direction associated. Kita just kisah pasal jarak dia berjalan. Whereas displacement, I am concerned about the final and initial because I want to know where should I put the arrow. Displacement is a vector, distance is not a vector. Okay, distance is not a vector. So distance defines the actual distance moved between any 2 points. The distance traveled is dependent on the path. Semut tu jalan bengkang-bengkok, lagi jauh lah dia kena jalan. So the longer the distance taken by the ant. Okay, so that is distance and displacement. We also talk about position vector and also reference point. So ada 4 term yang kita belajar hari ni. The next one is displacement of linear motion. Ya Allah kecilnya. Okay, linear motion is a motion along a straight line. Like I mentioned before. Jadi siapa yang jalan straight line tadi? Tak ingat dah siapa yang jalan straight line. Haikal jalan macam ni, melonjak. Oh, it was Fazrul. So Fazrul dia jalan straight line kan? Dia jalan dalam x-axis sahaja. So linear motion. So Fazrul is doing linear motion because dia berjalan dalam satu axis sahaja. Tak kisahlah axis ni y ke, x ke ataupun axis dia macam ni. It's still a linear motion asalkan it is on the same axis. Okay, so the reference point. Okay, this is the reference point and this is the final point. Okay, tak kisahlah ini. Ini gambar tak berapa clear. Okay, okay, that's it. Displacement. In 1D linear motion, we may represent linear displacement as delta x equals to x final minus x initial. I already told you this one. For linear motion, the magnitude of displacement is the same as distance traveled. Okay. So what does this mean? Tadi I talked about semut, right? I talked about semut and semut tu jalan macam ni. This is the reference point and this is the final point. Point A, point B. So the vector of displacement is this way. And this is the distance. This is displacement. Okay, but this is 2D. As you can see here, the distance, dia ada X and Y component. So it's 2D. So this is not linear motion. Kalau semut tu jalan macam ni, okay, dia jalan dalam straight line, maka the distance is equal to the displacement. So in 1-dimensional motion, the distance is always equal to displacement. But in 2D, the distance is not equal to displacement sebab dia jalan lagi jauh kan. Tapi kalau dalam distance 1-dimensional, dia memang akan equal to displacement sebab memang ini jarak yang paling dekat lah. Sebab ini memang jarak yang paling dekat. So that is your displacement 2. Your distance is equal to displacement in 1D. Your distance is not equal to displacement in 2D. Okay, that is something to note. Okay, all right. And then we talk about average velocity. We still talking about that ant. Saya tahu analisis semut ke tak? Okay, ada. Kesiannya ant ni. Okay, so this ant is traveling, like I mentioned to you before. This is the distance, this is the displacement taken by the ant. So Average velocity is actually displacement, the change in displacement over the change in time. Change in displacement. Okay, remember this triangle means the change in something. Change in displacement over the change in time. Okay, over the change in time. So what does the change in displacement mean? What does the change in this time mean? So bila kita cakap pasal change, delta, it is always final minus initial. Always, tak pernah initial tolak final. Kalau change in ataupun delta ataupun d, small d, is always final minus initial. So in this case, if I expand this equation, right, V average is given by benda Allah tu, I don't know what it's called. Average velocity is equal to RF minus RI. Sebab ada delta ni. Bila saya expand delta ni, RF minus RI. Sama juga macam time. Time final minus time initial. Okay. So that is how you use the equation for average velocity. So average velocity ni is a vector quantity. Remember, if you have a vector and you divide it by a scalar, it still becomes a vector. Time is a scalar. This guy, displacement is a vector. So vector divided by scalar gives you a vector. So vector quantity, the magnitude is the ratio of displacement to time taken because it's division. So it's called ratio 2. The direction is the same as the displacement. So if my vector is if my delta R is to the right, then my velocity is also to the right. Sebab dia vector kan, dia akan follow. Dia follow direction. Okay, so kalau R ke atas, maka the velocity also goes upwards. It follows the displacement. It does not follow time because time does not have direction. It follows the displacement. So the SI unit for velocity is meter per second. Displacement is in meter. Time is in second. So this gives me meter over second ataupun meter. You can write it like this as well. Sama. Meter per second, meter times second to the power of -1. Just say per second lah. Okay. So that is the equation for velocity. Ni average velocity. Sebab apa? Sebab kita tak kisah pasal, kita just want to know final minus initial. So immediately it's giving us the average. So why do we need to know about average? Because there's another term to this one. It's called instantaneous. Tadi kita cakap so average. Average tu average lah. Okay, so this is instantaneous. Apakah maksud instantaneous? It is in an instant ataupun in a second or in a very short time. Instantaneous means something that happens in a very short time. Okay, so now let's look at this semut again. Okay, semut ni dah jadi macam ni dah sebab saya malas lukis. So semut ni dia jalan macam ni kan. Okay, so dia jalan. So remember, velocity punya equation, general equation of velocity is displacement over time, right? So if the semut tu decides to stop over here sekejap, I can say that this is my reference and this is my first point, x1. And then semut tu jalan lagi. So dia stop kat sini. Second point. Jalan lagi. And then this is my third point where I finally end, where the semut finally ends his journey. So sepanjang kat sini kita ada 3 point yang kita boleh tengok velocity. So let's say the reference point is x0. Okay. So kita ada instantaneous velocity. V1 is x1 minus x0 over time. Time T1 lah. T1 tolak T0. Ni T1. This is the time yang semut tu berhenti sekejap. So T1 minus T0. So this is the instantaneous velocity from here to here. And then kat sini ada velocity lain pula. V2. Ni ada direction dia ke atas. Bawah pula ke sini. V2 X2 minus X1 over, semut ni sibuk. Sekejap. This is X0. Okay, so X2 minus X1, T2 minus T1. Direction dia macam ni because I am starting here, ending over here. That is the instantaneous velocity from this point to this point. And then sama juga V3. So this is my initial, this is my final. So my direction is this way. And this is X3 minus X2 over T3 minus T2. Okay, so I have three different velocities and these are instantaneous velocity. Dia ambil velocity tu pada duration yang lebih kecil compared to average. Okay, let me repeat myself. Instantaneous velocity is the velocity at a shorter duration of time compared to the average. Kalau average, kita ambil daripada sini ke sini. Kita ambil total displacement bahagi dengan total time. That is your average velocity. For instantaneous, kita ambil sekerat-sekerat je. Kita ambil sekerat. Direction dia pun berubah-ubah if you notice. So that is instantaneous velocity. It will be at a shorter duration compared to the average. So as you can see here, V instantaneous, dia tak ada simbol ni sebab ni bukan average. V limit of delta T approaches 0. Limit of delta T approaches 0. Maksud kat sini, duration of T is so small that it approaches 0. Okay, itu maksud kat sini. Delta T, arrow 0, it is so small, it approaches 0. Okay, so this gives me, so sepatutnya lah, kalau nak cakap pasal instantaneous yang sebenar-benarnya, kita cakap pasal in an instant. Yang sebenar-benarnya macam kecil ni je, velocity yang kita kena cari. So apa displacement dia? Displacement dia daripada sini ke sini, time dia daripada sini ke sini. So that is the smallest that you can get ataupun smaller lagi. So it approaches 0 in an instant. That is instantaneous velocity. Tapi selalunya untuk memudahkan kita, kita ambil yang duration yang kita senang kira lah. So saya cakap sini ke sini is your instantaneous velocity pun boleh asalkan dia smaller. The time duration is smaller than your average. Okay, so I hope that makes sense. It's a new concept to you, I think, but take your time to understand it. Does anyone have any questions? Spider Fazrul. Okay, ada soalan tak? Sorry ya Fazrul. Hari ni Fazrul punya hari, esok hari korang pula. So jangan nak gelak sangat lah. Okay, so no questions No questions. Everyone's okay about average and instantaneous velocity. Do you understand the difference? Okay, ada orang tulis kat chat. Okay. Masih bisa, faham. Okay, thank you. Ada soalan tak? Siapa-siapa ada soalan? Yang faham ada soalan pun tak apa. Yang tak faham ada soalan lagi bagus. Okay, so in average kita ambil total displacement over total time. Instantaneous kita ambil shorter duration of time. And kita tak ambil total displacement lah, kita ambil displacement kecil-kecil je. Okay, ke atas tu ke tu delta. Ke atas tu ada mana? Ada atas tu. Saya tak faham. Oh, okay, sorry. Doktor, DRDT tu kena buat pembezaan ke? Oh, okay. Sorry, saya tak perasan soalan tu. Okay, so kalau if you look here, it says delta R is over delta T is equal to DRDT. Pembezaan tu differentiation kan? Okay, boleh kalau ada graph. So let's say you have this graph. This is T and this is R, and taking the differentiation will give you the gradient. Wait. Okay, Taking the differentiation of this will give you the gradient. Ya, betul. And this equal kat. Saya rasa saya tak boleh cerita lagi pasal benda ni. Saya akan cerita dekat akhir nanti. Tapi soalan ME tu betul. This is actually differentiation, tapi for this one we don't use differentiation, we just label it dr/dt. Sebab kita boleh kira kan, kita boleh kira what is Rf minus Ri over T final minus Ti. So in this point kita tak cakap pasal graph lagi, so we don't have to differentiate anything yet. We just use the values. We plug in into the equation, okay? Okay, that's a good question. Tapi nanti kita akan belajar. And the D is actually the same as delta. Okay, the small d is actually, it means delta lah, the change in something. D is the change in something. Delta is also the change in something. That is the mathematical notation for both. Okay, kenapa macam fizik belajar banyak math kan? Saya pun tak tahulah, saya pun tak suka math sebenarnya. But memang ada dalam fizik. Okay, and then we talk about speed. Tadi kita cakap pasal velocity. Now we talk about speed. Speed is what? Number. Velocity is distance 4. And average velocity is 5. Banyaknya. And then instantaneous velocity is 6. Banyaknya. Okay, 7. So speed is 7. So semua term-term ni you have to know. Kena kan? Okay, so speed. What is speed? Speed of a particle is the magnitude of the velocity ataupun the total distance travel over the total time. So instead of taking the displacement, we are concerned about semut tu punya well-being. Kita nak tahu, okay, semut ni jalan berapa jauh sebenarnya. So kita tengok kat sini 100 km, ya Allah panjangnya. Tapi this is the total distance travel. So letaklah kat situ. And then the total time taken is 1 year. Kesian dia. So 1 year lah kat sini. So this is not SI unit. Kena convert lah. 100,000 meter. 1 year is, I don't know, 365 days, 24 hours, 60 minutes, 60 seconds. Okay, you know the drill lah. Kena convert to the SI unit to find the average speed because the SI unit is in meter per second. Okay. Janganlah guna semut kot, guna car. Okay, kalau car 1 jam je. The speed at a point is the magnitude of the instantaneous velocity at a particular point. Okay, tak apa. You just have to know that it is the total distance over the total time. Okay, tu je. And speed is the magnitude of velocity. So dia tak ada direction. It only has magnitude. Okay, so now let's take a look at this equation. Kita nak differentiate between average and instantaneous. So average ada this symbol. Kadang-kadang dia letak macam ni. Tapi sebab ada topi vektor ni, dia tak letaklah macam ni. Lebih senang letak macam ni. Senang nak bezakan. Sometimes you see X like this. This is average X. Okay, so it means average. This also means average. So average velocity is given by the total displacement ataupun final minus initial, the change in displacement over the change in time. And velocity, instantaneous velocity, you take it at a smaller duration of time. Typically, it is approaching 0. And then this is the change in displacement over the change in time. Tapi dekat short duration. Dekat short duration. Okay. And it can also be written as dx dt, which means small change. Small change. Small change. Small change in x over small change in t. Sebab dia approach 0. Kecil lah. Okay, small change. Kat sini tak ada dx dt tu. Sebab dia bukan small, dia besar. Change tu besar. So that's the difference. But this is just mathematical notation. What you need to know here is average velocity is the change in displacement, total displacement punya change over the change in time, instantaneous, shorter duration. Okay, and then speed is total distance over time. And then we go on to our next one, which is number 8. Banyaknya. What time is it? Lagi 8 minit. So let's finish at... Betul ke 8 minit? Baru pukul. Relax. Kita akan take a break after average. After average. after acceleration. Okay, kita akan take a break after I get to this slide. Is that okay? Sikit lagi. Kita akan take a break. Okay, next one, number 8 code. Number 8 code. No, this is number 9. This is 8. Average acceleration. Tadi we talked about average velocity, instantaneous velocity. Now we have average acceleration and instantaneous acceleration, which is the same thing, but now it's acceleration. So the units are meter per second squared. Sebab velocity is meter per second and then it is over time. So you get meter over second squared. Okay, it is a vector quantity because this guy is scalar, this guy is vector. It follows the direction of velocity. Acceleration is a vector because velocity is a vector. When the sign of the velocity and acceleration are the same, either positive or negative, then the speed is increasing. Okay, kat sini, sorry. Kat sini, acceleration dengan velocity boleh berbeza sign. Kita akan tengok example nanti. Acceleration and velocity can have different signs. Previously, I told you a vector has to follow the vector punya, kiranya kalau kat sini velocity, kat sini displacement, dia kena follow direction displacement kan? Okay, acceleration tak ikut macam tu. Dia pelik sikit. Acceleration can have different signs or have the same sign as velocity. Kalau they have the same sign, let's say acceleration is positive, this also is positive, V final positive minus V final initial negative, minus V initial positive as well. Okay, kat sini dia positif kan? Ni pun positif. Then the speed is increasing. When the sign of the velocity and acceleration are in opposite direction, the speed is decreasing. Okay, so this one kita tak nampak lagi macam mana rupa dia. That's okay. Kita akan go over later. So just remember this point first. If they have the same sign, the speed is increasing. If they have opposite sign, the speed is decreasing. Dan kita akan tengok in an example later on. And then instantaneous acceleration happens over a shorter duration of time. Kita ambil instantaneous velocity lah. The velocity that happens over a very short duration of time. So that is the instantaneous acceleration. Okay, over time. Okay, so ways an object might accelerate. The magnitude of the velocity can change direction. Okay, never mind this one. Okay, for linear motion, I told you just now, for linear motion, displacement and distance is equal. Okay, untuk linear motion juga, the directions of displacement, average velocity, instantaneous velocity, average acceleration, instantaneous are always along the same straight line. So linear motion ni sangat mudah lah. So if you are moving in one direction, the direction of displacement, average velocity and instantaneous velocity are along the same straight line. So semua berlaku dalam satu axis is what they are saying here. Adakah jawapan dia akan sama direction? Tak semestinya. Tapi distance dengan displacement will be equal in a straight line. Okay. So I know it's a lot of terms and it's a bit confusing. Bear with me first. Okay, so change in position. Position is given by X or S or R. Boleh. Change in X means final minus initial. Change in X, final minus initial. Change in T, T final minus T initial gives me velocity. Change in V, V final minus V initial. Change in T, T final minus T initial gives me acceleration. This can also be written as dx dt. Acceleration is dv dt. Looks like differentiation. It is. If you have a graph or if you have an equation, you can use this. Okay, so let's take our break. Let's take a 7-minute break. Come back at 3:04. Okay, go to the toilet, take your water, whatever. Let's come back later. Ada soalan boleh tanya. question.
Doktor,
Mm-hmm.
yang instantaneous acceleration tu doktor tak terang ke?
Mana?
Instant, instantaneous acceleration
Oh, okay. Instantaneous acceleration tu
tadi.
saya nak bagi example later. Boleh?
Oh, boleh boleh.
Sebab dia susah sikit. Average dengan instantaneous acceleration. Saya akan bagi kemudian. Okay, let me look at the chat. DRDT tu sama lah. Oh, ni soalan tadi. Dengan RF, RI, KFTI. Betul. Sama. Cuma kebiasaannya D ni, D, the small d, refers to a small duration of time. Tapi dalam kes ni boleh pakai sama. Delta R is equal to DR. Sama je. DT. Boleh. Kat sini sama. When you get to higher level physics, nanti dia tak sama lah. Benda ni akan membawa maksud smaller duration. Okay. But boleh, sekarang ni boleh pakai. But I prefer you guys to use the delta sign, delta sign. So that you don't get confused between differentiation or sebab delta ni kita tahu straightforward it's my final minus initial. Okay. So kalau dr dt ni, dr over dt ni macam usually you use it for equations lah. Doktor, yang limit dekat formula tu hanya untuk instantaneous je kan? Betul. Limit of t approaches zero only for instantaneous because we are talking about an instant or a second or a small duration of time. So delta t approaching zero hanya untuk instantaneous lah. Both for acceleration and also velocity. Saya tengah fikir example untuk acceleration. Oops, terlebih masa pula. Okay. Share. Okay, let's talk about acceleration. Balik. Cakap pasal acceleration balik. Okay, so imagine lah. Look at this diagram. And you can see that kita biasa dengan train, right? Everyone has ride a train before. So a train, when it approaches the station, it goes slower, right? It goes slower. So despite it moving from here to here, korang nampak kan ni kan? It moves from here to here. Walaupun dia bergerak ke arah depan kita, out of the page, it's going out of the page, but it is moving slower. Daripada sini ke sini, dia contohnya dia 50 meter per second. Apa jadi dengan gambar ni? And then kat sini ke sini dia 40 meter per second, and then ke sini 30 meter per second. So the velocity keeps on changing, tapi dia change makin berkurang. Okay, let me repeat myself. Okay, harap tak ada yang confused. So train ni dia nak berhenti dekat station. So dekat sini velocity dia 50, kat sini velocity dia 40, kat sini velocity dia 30, 20, 10 sampailah dia reach 0. So we know that there is a change in velocity. Right? Okay, now let me take a screenshot of this guy. There is a change in velocity. Screenshot muka sendiri, tak apalah. Malas nak buang. Okay, let's go back to our slide. Share screen, slide. New slide. Okay, let's talk about this instant. Kenapa ni? Saya tak ambil ke yang tadi tu? Sekejap. Insert picture from file. Screenshot. Okay, so this is the screenshot that we took just now. I took. Okay, and my face is there. Let me crop it. Wow. Okay, so I told you it's moving from here to here. This is the position vector. This is x. And the change in position. We know this. This is easy. But there is also a change in velocity. Sebab apa? Sebab it has to keep on decreasing its velocity if it wants to get v equals to 0 over here. Kat sini dia laju gila. Nak stop jadi kosong kat sini, dia kena constantly change the velocity. 40, 30, 20, 10 sampai jadi kosong. So there is a change in velocity. And the final velocity is 0. Let's say kat sini dia punya initial is 50 meter per second. So what is my acceleration? Acceleration is, kita anggap daripada sini ke sini lah, average kita, average acceleration is the change in velocity over the change in time. And from here to here, it took the train 10 seconds to come to a complete stop. Daripada point yang sini, hujung ni sampai ke sini 10 seconds untuk dia sampai and berhenti. Okay, so if I started from 50 and I ended at 0, what should I put into my equation? Anyone wants to try? Salah tak apa, macam biasalah. Salah tak apa, kita belajar sama-sama. Anyone wants to try? What happens? What is the equation for this train? 0 minus 50 over 10 second. Haikal tulis apa ni? Ni menangis ke apa? 0 minus 50 bahagi 10. Oh, Haikal tulis 0 minus 50. Okay, so kita try. Let's see if it's correct. Anyone wants to try? Anyone else? So ramai yang cakap 0 minus 50. Kenapa bukan 50 tolak 0? Final minus.
Sebab dia final tolak.
Yes.
Initial.
Okay, betul. Thank you. Final minus initial. Pasal ada S kat tengah tu. S mana pula? Oh, okay, jawapan Amy tadi. Okay. So betul So because there is a delta punya simbol kat sini, it's always final minus initial. Kalau ada lecturer yang cakap initial tolak minus final, salah lecturer tu salah. Korang betulkan dia. Okay, so it's always final minus initial. Which is 0 minus 50 meter per second over the change in time. So kita tak tahu kita kat sini pukul berapa, kat sini pukul berapa. Yang kita tahu duration is 10 second, which is good enough because it gives us the change in time. So 10 second. Okay, so this gives me minus 50 over 10, minus 50 over 10, which is 5, then 5 meter per second squared. Minus, I have a minus here. Velocity is going out. Velocity is this way. Tadi pula kita cakap pasal minus. So what does the minus indicate? It indicates that it is decelerating ataupun berkurang dalam velocity. It is decreasing in velocity. It is decelerating. Change in velocity is negative. Velocity keeps on decreasing. Keeps decreasing. So this is what is happening at the train. Velocity is, kita akan anggap this is positive sign lah. Velocity is going in the positive direction, but it keeps on decreasing. This gives us negative acceleration because acceleration is the change in velocity. Okay, let's go back to the point that we studied earlier. Kita cakap pasal signs. I don't remember which slide. Okay, when the sign of the velocity, kita cakap yang keluar ke sini positif. Okay, this is V. When the sign of the velocity and the acceleration are the same, then the speed is increasing. When the sign of the velocity is this way, jawapan kita dapat negative A. And the acceleration are in the opposite direction, the speed is decreasing, which is what happened. Kita nampak dia mula-mula velocity dia 50 and then finally the velocity is 0. The speed is decreasing. That is why you get a negative acceleration. Okay. Is everyone clear on that at least? Okay ke everyone?
Okay.
Okay, clear. Okay, clear. Yes, agree. Decelerate. Okay, speed reduce. Nyah pecutan. Nyah pecutan apa? Acceleration Okay. Okay, so that is your acceleration lah. Okay, what happens if the train, right? Kita use the same example. Okay, kat sini ada tengok. Kalau korang tengok kat sini, acceleration dia terbalik arah dia. Because so kalau dia terbalik, arrow dia terbalik, kita tak perlu letak negative sign tu. We just have to say 5 meter per second squared in the opposite direction as velocity. But if I don't indicate with an arrow, I have to say minus 5 meter per second squared, which is kalau kita tak lukis arrow lah, okay? So kat sini kalau dah ada arrow, I just have to say it is moving in the opposite direction by 5 meter per second squared. Okay, so that is when the train is decelerating. Okay, so let's take a look at another example of acceleration as well. What if this train is not supposed to stop here? Okay, it's not supposed to stop here. This is not its stop. It has to move. It has to move. So dia daripada sini, mula-mula dia kat sini 70 meter per second. And then kat sini dia lagi laju sebab dia nak pergi ke next destination, which is not here. So it's moving to the next destination, 100 lah. Now at this point, it is 100 meter per second. Velocity direction is out of the page. This is the positive direction. So what is my acceleration? How do I write this equation? And the duration of time is 10 seconds. What should I write here? Should be easy now.
100 minus 70.
70
Divide
over 10. And you get 30 over 10, which is 3 meter per second squared. So the sign here is positive, which means that the speed keeps on increasing. Okay, what happens if the train is 70 here and also 70 here? over 10 seconds. What happens? What happens
No
to
acceleration.
acceleration? There's no acceleration. Acceleration becomes 0. Okay,
Constant
let's set it up.
velocity.
70 minus 70 over 10 gives me a 0. Acceleration, when acceleration is equal to 0, it means that your speed is constant. Okay, speed or the velocity is constant. So 70 here, 70 at the final. It's a constant speed, so you get 0 acceleration. If you have positive acceleration, it is increasing in speed in the same direction as velocity. If it's a negative, it is decreasing in speed in the opposite direction of the velocity. Okay, so those are the three examples lah. So instantaneous ni susah sikit nak cerita sebab kita kena guna graph. Like Amy mentioned before, kita differentiate. So let's take a look at the graph. I hope I'm going to explain it right. Ini apa? Dia boleh pakai ke? Ya. Tak boleh. Ni average. Okay. So this is a velocity. Oh sorry, saya belum share lagi. Share. Okay, did I miss any questions? 0, agree, constant V. Okay, good. Everyone got it? So now let's take a look at this. We are talking about instantaneous acceleration. It is expressed mathematically as d dt, differentiating velocity with respect to time. Okay, dv dt or d dt bt. Sama. Okay, so this is an equation. Sorry, this is a graph of velocity versus time, right? Time 1, time 2, time 3, time 6. Kenapa kat sini time 0? Tak tahu kenapa. And then we have velocity as the y-axis. I think I need to screenshot so that I can counting. Kat sini tak ada counting. Sekejap susah nak counting. New slide. Stop sharing. Share. Constant. Insert file. Screenshot. Ni tadi. Did I took the screenshot or not? Okay, this one. Wow. Make it smaller. Sekejap. Technical errors as usual. Okay. So let's talk about this one. Make it bigger. Okay. So now we're talking about instantaneous, acceleration, which is the acceleration, but at a shorter duration of time. So here we have a graph, and in the graph of velocity versus time, instantaneous acceleration is the slope of the tangent line. It's the gradient lah. It's the gradient of the tangent line. So what on earth is tangent line? It is a straight line. This is a straight line. Straight line. This is tangent. This is a weird tangent actually. Patutnya tangent macam ni. Sekejap. This is weird. Sekejap. VVT delta T. Oh, okay. Okay. So dia ada banyak time kat sini. So this one is talking about the tangent between time 6 and time 1. This is between time 5 and time 2. And this is time 4 and time 3. And this is at a single time. So ni yang sebenarnya lagi, this is what we call as instantaneous at a single time. So when we have a graph of velocity versus time, bear with me first. When we have a graph of velocity versus time, right? And the graph is a curve like this. The graph is a curve like this. And I say, okay, what is the instantaneous acceleration at this point? At this point. So how do you do it? You find the gradient of this. You find the gradient of this tangent line. Tapi kat sini dia buat untuk duration yang besar, which is not accurate sebenarnya. So another case of instantaneous, I say, okay, what is the instantaneous at this point? So what is the gradient here? Can anyone tell me? What is the gradient here?
0.
0, which means that the speed at this point is constant. There is no acceleration, or the velocity is constant. Okay, as you can see here, kat point ni sahaja, speed velocity tu tak berubah. Velocity tak berubah, which is why the acceleration is 0. But at this point, the velocity changes. At this point, the velocity changes from 10 ke 15, contohlah. And then kat sini, daripada 15 ke 17. So ada perubahan. There is a change in velocity. So your gradient will be positive. And then when you reach this point, there's no change in velocity. So the instantaneous acceleration is equal to 0 at this point. And then when I talk about this point, the instantaneous acceleration is a minus something, minus 10 maybe. At this point, what is the instantaneous acceleration? Minus, dia lagi turun kan, dia lagi turun, so lagi tinggi, minus 15. Okay, so instantaneous acceleration is dependent on the gradient of where you are measuring the acceleration lah. It depends on the time. So let's say I want to know what is the instantaneous acceleration at time t4. So this is the gradient that you need to look for if you want to know the instantaneous acceleration. Okay, so looking at this graph, how do I find the average acceleration? Anyone wants to try? How do I find the average acceleration from this graph? What is the definition of average acceleration? V delta V over delta T, or V final minus V initial over time. So how should I do it? No one wants to try? So this is V final lah. Okay, V final, this is V initial. So the average acceleration is from here, so here to here, V final minus V initial time T7 time T0. V final minus V initial, whatever that value is, T7 minus T naught. Okay, so average acceleration, total change in velocity over the total change in time. Instantaneous, I'm only concerned about the acceleration at time T4. Over here, I'm only concerned about the acceleration at time T2. It's a negative, sorry, this is a positive acceleration. This is a negative acceleration. Slope dia ke bawah. Slope ni menaik, positif. Slope ke bawah, negatif. Slope data, kosong. That is acceleration. Kenapa from this graph we get acceleration? Because acceleration is dv dt. When we differentiate this graph, which is dv dt, we get acceleration. Okay, ni pengenalan dulu. Siapa yang rasa macam susah, tak apa, you still have time. We're not yet at the end of this chapter. Okay, so that is instantaneous. You have a graph, you are only concerned about the gradient at that point. This is for acceleration. What about displacement? What about displacement versus time? What about velocity versus time? What about acceleration? Acceleration versus time, tak ada. So let's go over this problem. Okay, hopefully it will help us with our understanding. Do I have any questions so far? Or let me look at the chat. Final V minus T6. Final V over T6. Dia kena ada change, kena ada gradient. Okay. Tu menjawab soalan Amy. Okay, so example 2.1. A motorist drives north for 30 minutes at average speed. Okay, average speed. Let's say 80 km per hour. So this is V1. Okay, this is speed sebenarnya. Tapi dia ada direction north. Let's put it north. Okay, 80 km over hour. And then stops for, this is 30 minutes. T1 is 30 minutes. Okay, and then he stops for 15 minutes. V0. 0. T2. Sorry. V0. V2. T2 is 15 minutes. Okay. And then he continues east. Yang ni dia tak bergerak. So it's just staying there. And then he continues east over here. V3. 130 kilometer. Oh, this is the distance. 100 kilometer in 2 hours. So velocity over 2 hours. Ataupun T3 is 2 hours, and I don't put this as velocity, I put this as distance, x, 130 kilometer. Now, the question is, what is his average speed? It's asking about average speed. And then what is the average velocity? Now, remember the definition for average speed versus velocity. So, for average speed, it is the total distance, sorry tulisan buruk macam biasa, total time. Okay, and then we have average velocity. Okay, total displacement over total time. Okay, so I'm gonna give you guys 7 minutes macam biasalah. And then I will call out someone, or let me just identify someone here. Saya nak Lutfi for speed. Lutfi. And then Molly for velocity. Okay, let's try it. For the rest of you, please try it yourself and see if you get the same answer as the answer here. Okay. So how should you do it? How should you find the total distance versus the displacement? Seven minutes, eh? Hmm. Dah ke? Is it time yet? Forgot this to time. Is it 7 minutes yet? Okay, is Luffy ready? Is Luffy ready to answer? Luffy, are you there? Ketiduran ke Luffy ni? Oh, ada chat kat sini sekejap. Kejap doktor, okay. Mungkin dia dapat ramai dia Luffy. Okay.
Doktor, R2 displacement
Lagi sekali, R2,
Displacement ke?
R2 kat mana awak tengok ah? Equation ke? R2 mana awak tengok ni?
Untuk kira average velocity kan ada yang apa ni, delta R dengan delta R2 over delta T tu kan. Yang R2 displacement ke?
R2
Untuk
displacement. R2 position vector. So position final minus position initial gets you change in displacement. Faham tak? Tapi displacement lah, displacement. Delta R, delta T. This is delta distance atau S code. Delta T. Okay. Molly and Luffy. Okay, let me remove this first. Betul kalau 17.1 degree tu wajib tulis ke? Yes, sebab dia velocity ada direction. So wajib. Untuk speed hanya nombor sahaja. Dengan units. Okay. Luffy dah ready ke? Or still need time?
Dah.
Okay. So how is
Average speed, total distance dia 170.
PS speed 170.
Total time 2.75 hours.
2.75 hours. Okay.
Answer dia 61.82 km per hour.
Okay. Boleh tak cerita macam mana awak kira distance ni? And time.
First cari distance dekat masa dia drive dekat north dulu.
Okay.
Pakai formula total distance over total time lah. Ganti-ganti.
Distance
Lepas
yang
tu
pertama,
dapat total distance yang pertama dapat 40.
cara nak kira.
Cara kira dia average speed dia dah bagi 80
Okay.
equal to darab dengan masa dia.
Tapi masa kat sini 30, jadi
Darab dengan 1/2 0.5 hours.
okay, 0.5 hours. Which is 30 minutes lah. Lepas tu dapat 40.
40.
Okay. Okay, so the next distance. Yang ni distance ada tak? Second one.
Tak ada.
Okay, tak ada 0. And then the third one.
The third one 130.
So 130 tak payah buat apa-apa lah. Okay, what about
Ah.
total time?
Tak clear doktor.
How did you calculate the total time to be 2.75?
2 hours plus 0.25 plus 0.5.
0.5 hour. Okay. 30 minutes is equal to 0.5 hour. Lutfi dia tukar siap-siap. This is 0.25 hour. Walaupun kat sini kosong, masa dia still ada sebab dia dikira dalam total time. And then the answer is 2.75. Okay, thank you Lutfi. That was good. 2.75.
Okay.
Okay, so saya repeat balik apa Lutfi cerita tadi. So mula-mula Lutfi cari distance. So 80 km per hour darab dengan 0.5 hour sebab dia bergerak sebanyak 30 minit sahaja pada kelajuan ni lah. So darab 0.5. 30 minit bersamaan dengan 0.5 hour. Okay, kalau nak pakai cara conversion yang saya ajar sebelum ni pun boleh juga. So you get 40 kilometers here, and then for number 2 the distance is 0, and number 3 dia bergerak ke east sebanyak 130 km. So terus pakai kat sini, tak ada convert apa-apa dah. And then in terms of time, T1 is 0.5, T2 is 0.25 sebab 15 minit, T3 is 2 hours. So ditambah semua kat sini. This is the total time, and then this is the total distance. Okay, and then you get 61.82 km per hour. Okay, Molly, can you tell us how to find apa tadi? How to find
Average velocity.
Yeah.
Apa yang saya dapat lain lah, doktor.
Okay, so how did you do it? Let's see. Tak apa. Macam mana Molly kira?
Cara saya kira senang lah. 80 plus 0 plus 65 over 3 equal to 48.3.
65 sebab bahagi 2 hour Okay. Okay, so Molly dia tambah macam ni. Molly said average speed is V1 plus V2 plus V3
Over 3.
over 3. Over 3. So average velocity over 3. So V1 is 80 km per hour
48.
plus 0. Oh, yang ni Molly kira as 40.
Bukan 80.
Oh, 80. Okay, so this is 80. V2 is 0 and V3 is 130 over 2 hours divided by 3. Okay, let's see. 80 plus 0 plus 100. Dapat 48.33. Molly dapat 48.33 ke?
Yeah.
Okay, so let's just keep it here first. 48.33 kilometer per hour. Okay, so Molly kan dia kira average ni dengan cara yang simple. V1 plus V2 plus V3 divided by 3. Okay. Sebenarnya tak salah, but the actual way to be very precise about this is to find out what is the displacement over the total time. Yang tu yang cara yang paling precise lah. Yang ni macam estimation. Okay. So let's do it. Velocity is the change in displacement for x, change in displacement over the change in time. And then kita ada 30 minutes north at average speed of 80 km. So dia bergerak sebanyak this much 40 km mula-mula. Okay, and then time dia ialah 30 minit. And then dia berhenti. He stop for 15 minutes and then he continues east travelling 130 km ke sini. Okay, so what is his displacement in this case? It's from initial to final, right? This is the displacement vector. Okay, so kita ada 40 kat sini. Let's try to 30 kat sini. Using Pythagoras theorem, I would get 40 squared plus 130 squared. Square root of that, I will get 136. So this is my change in position vector or change in displacement. So 136 kilometer. 0.01. 136 Okay lah. 2 decimal points. 136.01 kilometer. Okay. So the change in time. So total time still sama. 30, 15 and 2 hours. Okay, so this is 0.5 hour. This is 0.25 hour and 2 hours. So you get 2.75. So 136.01 over 2.75 hour. This is change in displacement over the change in time. So divided by 0.75. Dapat 49.46. Okay. So apa kelemahan cara Molly ni? What is the one weakness that we can see from Molly's calculation? What is the one weakness? Apa dia?
Tak dapat arah.
Yes, correct. Molly's way gives us the estimation of the value, but it doesn't give us the direction. So boleh pakai, kalau dia tak kisah pasal direction, boleh pakai as an estimation. But the precise way of doing it is to find the displacement vector. Okay, which is pakai Pythagoras theorem lah. Kena lukis, cari dia punya resultant. Sama je macam chapter 1 like we learned earlier. These are vectors too. A vector, B vector, resultant vector. Sama. Okay, but in this case, the resultant vector is in displacement. Okay, and then total time, you get the answer. And for the angle, we can find the angle. How did you guys find the angle? Is there a way that you found the angle? Ada tak? Siapa-siapa yang dah try and got the angle? 17.1. No one? Tak ada orang nak try? No one got it? Okay, let me see the chat. Tangent. Tak boleh cari direction. Cari pakai tangent. Okay, Emmy, how did you find using the tangent? Tak dapat 12 ni. Tak dapat C. Opposite over adjacent. Tu one. Okay. Tangent. Inverse tangent of, let's see, saya try juga. Inverse tangent of 130 divided by, sebenarnya saya tak try lagi soalan ni. 130 divided by 40, so I get 72. 90 minus answer, I get 70.10. Boleh dapat, betul? 130 over 40. Okay, so how did I do it? How did I get the angle? So this is 130, this is 40. I want to know what is the angle over here, right? So I can use tangent. tangent theta equals to opposite over adjacent. Opposite is 130 over 40 and theta is 72.897, 72.9 lah, 0.90 degrees. This is the angle theta here. I want to know with respect to the x-axis. What do I do? 90 minus 72.90. So you get 70.10. Okay? Always refer back to the x-axis. Bila masa kita tak perlu refer, masa kita buat cross product, masa kita buat dot product. Waktu tu tak kisah x-axis. We just want to know the angle between the vectors. But when you are dealing with vectors like this, addition, subtraction, multiplication, always refer back to the x-axis. Always. The answer always refers to the positive x-axis. Okay? What time is it? Okay, we have time. Any questions about that question? Any question about that one? Okay tak? Is everyone okay? Walaupun tulisan saya sangat tak cantik. Faham tak? Makcik okay. Okay. Okay, any question dari doktor sudut tu ambil atas ke bawah? Ambil yang referring to the x-axis. This is not x-axis, this is x-axis. Okay. So yang ni untuk total distance. Yang ni untuk velocity, average velocity. Okay. Yang ni cara lagi satu tapi tak memberi kita direction. But it's not incorrect. It's just another way of doing it. Okay. Alright. So I hope everyone is okay. Doktor, kalau kata 72.9 east of north pun boleh. 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 Boleh juga. Oh betul lah sebab kita punya soalan east, north semua tu kan. Boleh. Alright. Okay, moving on. One more and then kita habis kelas. One more. Let's see. Dekat mana saya boleh cover. Okay, I think I'm gonna end class here lah. Okay. Sebab nanti kita kena masuk yang ni pula. Yang ni panjang cerita. So I'm gonna end class here. If you have any questions, you can ask them now. Okay, remember what have we learned today? Kita belajar pasal average velocity, which is the change in displacement over the change in time. Berbanding dengan instantaneous, we take at a shorter duration of time. If we have a graph of displacement versus time, let's say this is x and this is t, and displacement is like that. If I want to find the average velocity, I need to know what is the x final and the x initial. And then this is t final and this is t initial. So average velocity is x final minus x initial over t final minus t initial. Whereas instantaneous velocity is you take the gradient at a certain time. Let's say I want to know what is the instantaneous velocity at T4. T4 kat situ. So you take the gradient over here. That gradient will be your instantaneous velocity. Oops, sorry. Tak boleh buang. Okay, so the gradient at that point, gradient yang kecil kat sini, is your instantaneous velocity. Can you find the gradient for average velocity? Boleh, but it becomes like this. Okay, so baik pakai equation lah. Okay, sebab sama je macam equation pun, pakai x final tolak x initial, t final tolak t initial, sama. Macam korang lukis gradient juga. But for instantaneous, kita concern dekat gradient of that particular time. Okay, so this is displacement versus time. Sama juga velocity versus time. Kita akan dapat acceleration. Let's say this is our velocity versus time graph. So if I wanted to know what is my average A, I have to know what is the V final, what is the V initial, and what is the T final, and what is the T initial. So VF minus VI over TF minus TI, or delta V over delta T. Whereas for instantaneous, let's say I want it over here, this gradient yang kecil cenonet ni, that gradient at that point is the instantaneous at time x, whatever that time is. Find the gradient over there, you will get the instantaneous acceleration. Okay, gradient is equal to instantaneous, blah, 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 acceleration. Okay, and then we also talked about positive acceleration means, positive acceleration and positive velocity means that your speed is increasing. Positive velocity but negative acceleration, your speed is decreasing. Okay, so I hope that helps. I'll see you guys Thursday. Betul. Tak ingat. I'll see you guys later this week. Bye. Take care. Oh, ada lagi soalan?
Thank you,
Saya
Doktor.
ada soalan.
Okay,
Tu
doktor.
tengok kat chat. Tengok chat.
Okay, doktor nak tanya tadi average velocity tu kenapa bahagi 2.75 bukan ke change of time? Okay, so average velocity is the change in displacement over the change in time. Sebab total time, kita still pakai total time. Average pakai total time. Kalau instantaneous baru pakai short duration of time. Faham tak Aikal? Average pakai total time. Okay, alright. So siapa yang dah dapat access to web assign nanti boleh start your assignment. Alright, so take care. Bye guys. Thank you. You're
Bye,
welcome.
Doktor.
Bye-bye.
Thank you.
Thank you, Doktor.
Terima kasih doktor.
Bye.
Salam.
Mm.